Today's video will demonstrate the class diagram of the binary search tree. Hello, I'm James Helfrich. The binary search tree is not one of the built-in containers provided with the standard template library, but rather it is the underlying data structure of both the set and the map. This video will explain how the class diagram for the binary search tree works. The BST class consists of a collection of bnodes and a companion nested class. Now, the BST is not a container per se. In other words, there's not an instance of a BST in the standard template library, but rather we build the set and the map from it. And since the BST is a provider for the set and the map, we consider the BST to be a bridge design pattern. Now, we're going to start with the standard interfaces. We're going to have a constructor, a copy constructor, and a destructor. We're also going to have the other standard container interfaces, assign, clear, size, and empty. Now, in order for me to implement size and empty, I need to know how many nodes there are going to be in my binary search tree. And so I have to have a number of nodes attribute. And it's going to be a private integer attribute. It's actually going to be a size t, which is an unsigned int. I'm also going to have an insert, and it's going to insert a t into my binary search tree. And that t means this is a template class. I'm also going to have a race, which will remove a given node in the binary search tree, which takes an iterator. Therefore, I must have an iterator class, which is going to be a nested class of the BST. And there's other interfaces that use the iterator as well, such as find and begin and end. Now, my BST itself is going to consist of a collection of nodes. So I need to have a member variable called root, which is of type BNode. So I need to have a BNode, which is going to be a nested class, just like the iterator. Now note, the iterator is a public nested class. In other words, the client can instantiate a BST : iterator, but the BST : BNode is a private nested class. In other words, only methods within the BST class itself can instantiate or reference a BNode. So not only is the BNode related to the BST as a nested class, it's also an association. And what type of association? Composition. In other words, the BST is going to create and destroy bnodes. How many of them? Many. It could be 0 if the BST is empty, but it could be an arbitrary number. So let's dig into that bnode a little bit more. First of all, the bnode is going to have a constructor default and a constructor non-default, which will instantiate a bnode with a t variable. And the reason why we have constructors is because we want to be able to initialize out our pointers. So our p left, p right, and p head pointers are set to the null pointer. The bnode will also store a data item of type t, which means that there's going to be a t which can be related by association. But what's the association? Composition, because the bnode is going to create and destroy that t, and there's always going to be exactly one. Now notice this t is defined as a template in the BST class, not in the bnode class. Additionally, I'm going to have 3 other attributes: p left, p right, and p parent. All these are type bnode. And this can be related by aggregation. In other words, one bnode will refer to another one, but will not create and destroy the other ones it's pointing to. And how many will I have? Well, 0 to 3. 0 in the case that I am the only node in the binary search tree. 1 in case I have just a parent, or 2, or even 3. The only time I'll have 3 is when I both have a parent and 2 children. Additionally, I'm also going to have an isRed, and it's going to be a Boolean, and it's going to tell me whether I'm a red node or a black node when I do red-black balancing. I'm going to need some other methods to help me with my balancing, and it's going to include verify red-black, which is going to make sure that my red-black nodes are set correctly, verify BST to make sure every left node is smaller than or equal to the current node, which is less than or equal to the right node, as well as balance, and balance will actually conduct the red-black balancing. Now observe that my attributes, my data, p left, p right, p parent, and isRed are all public. And why are they public? Because the BST is going to have to manage these. The insert and the erase and the find and the empty are going to have access to those bnodes. There's no point in encapsulating them, making them private, because the BST is going to be the only one who knows about it and is going to do all the work to manage them. In other words, it's the relation between the nodes that is the difficult part, which the BST manages, not the node itself. Okay, let's dig into that iterator a little bit more. That iterator is going to have a constructor as well as a non-default constructor, which will be able to initialize itself to a given bnode, as well as a copy constructor and an assignment operator. I'll also be able to see if 2 iterators are pointing to the same node or not, with equals or is not equals. And I'll be able to advance my iterator both in order and opposite order. And last but not least, I'll be able to dereference the iterator, which means I'll be able to fetch the value. In order to do that, I must have a pointer to a BNode, and this pointer is by aggregation. In other words, the iterator does not create or destroy BNodes, it only refers to them. And how many am I going to have by aggregation? 0 to 1. 0 in the case I'm the null iterator, otherwise known as the end iterator, and 1 when I'm pointing to an actual node. Now, there's one final thing I need to do to finish out my BST. I have a couple private methods which will help me with my work. Delete node, delete binary tree, and copy binary tree. The reason why we have these is because these are recursive. It's far easier to implement these guys recursively rather than iteratively, and they're private because they're going to make use of the specific knowledge of the B nodes. Notice they take B nodes as parameter, and therefore for abstraction reasons, we do not want to give the client access to them. We can learn more about the implementation and the class diagrams of the BST class in the implementation section of the BST chapter of the C++ data structures textbook.